Yesterday we have ended till here. Just give me a minute, please. So in the next part, what they have been asking, you have to state and explain the effect on yield of Cl2O6, that how much it is produced, whether greater or smaller or lesser, when the experiment is carried out. So they have provided you two conditions. One is that 100,000 Kelvin temperature and 100 kilopascals pressure. So that's what we did in the last class. So see, the enthalpy change is telling us that the reaction is exothermic, and the rule that we have studied is that increase in temperature favors the equilibrium to shift towards endothermic side. So see here, at the temperature is 1000 Kelvin, which is a relatively very high temperature. So it means that the reaction would shift towards the endothermic side, and the endothermic side is the backward side. So that's how, when the temperature is this much high, the reaction occurs, the backward reactions occur, and as a result, what happens to the yield of Cl2O6? It decreases. That's what we have, that's what where we have ended the class. Now, if you see, in the next part, the temperature is 500 Kelvin and the pressure is 500 kilopascal. So if we look in terms of temperature, what we did, the temperature is decreased. So when the temperature is decreased, equilibrium shift towards exothermic side. It means the equilibrium shift towards right. So if the equilibrium shift towards right, what happens to the yield of Cl2O6?
Increases.
It increases. Now, if you look at pressure, what we did with the pressure relative to, we increase the pressure. And if you recall the rule, very good. When we increase the pressure, equilibrium shift towards the side where there are lesser moles of the gases, right? So if you see over here, there are only 3 moles of gases. And on the reactant side, we have 4 moles of gases, and here 3 moles of gases. So again, on increasing the pressure, equilibrium shifts towards right. And as the equilibrium shifts towards right, more amount of Cl2O6 would form. So what we will write, we will first state that what happens to the yield. So that in this case, yield of Cl2O6 increases. And we have to explain the reason as well, right? So one thing that right side has fewer moles of gases, and equilibrium shifts to right as forward reaction is exothermic. Is this clear to all of you? Okay. Now we have a next part. Element E is a period 5 element. Okay. E reacts with oxygen to form an insoluble white oxide, and it has a melting point of 1910 degrees Celsius. So which oxide it is? It is a ionic or a covalent. What is the possibility?
It's insoluble. Conducts electricity.
And E conducts electricity when liquid. Yeah. So see, this will helps you to identify that it's ionic. If this statement is not there, then it can be giant covalent or ionic, right? So this condition that E conducts electricity when liquid, it means in liquid it has a free ions, free moving ions, right? So from this we can conclude that this oxide is an ionic oxide. Is this clear to all of you? Okay. E also reacts readily with chlorine to form white solid that reacts exothermically with water. Okay. So it means it's forming, when it reacts with the chlorine, it forms its chloride, which is white in color. And when it reacts with water, the energy is released. The delta H is negative. Okay. The resulting solution reacts with silver nitrate to form white precipitate that dissolves in dilute ammonia. So obviously these white precipitates are of AgCl, silver chloride, which turns which are soluble in ammonia. Okay. Now, what they are saying suggests the type of bonding shown by the oxide of E. Explain your answer. So we will write it has ionic bonding because in liquid or when liquid, it has free moving ions. Is this understandable? Yeah, electrons are not, if there are electrons, then it do conduct electricity in a solid as well. So yeah, and it's an element. Remember, elements have a free electrons. Compounds do not have a free electrons. Okay. Yes, Adi, you can write only one condition as well in the last part. Next. Suggest the type of bonding shown by the chloride of E. Explain your answer. Okay. So if we'll see over here, white solid, that is a chloride, and it reacts exothermically with water. So what does this thing further telling you? Which compound reacts with water? No, that usually do not happen, Hadi. And if one condition opposes, then there will be probably no change in the position of the equilibrium, if that is the case. Okay. So it is indicating us that their reaction is hydrolysis. See, and which compounds do hydrolysis? Covalent compound do hydrolysis. So its chloride is covalent. Because if we talk about ionic, do ionic compound reacts with water? No, they just dissolves and splits into ions. And when the statement is this, that a compound is reacting with water, so the reaction occurs with the covalent compounds because covalent compound hydrolyzed in water. So from this, I can conclude over here, the type of bonding is covalent because it is hydrolyzed or it undergo hydrolysis in water. Is this understandable to all of you? Okay. Now we have a next question. The reducing agent LiAlH4. Okay. You guys need to remember one thing about this one that we have discussed in organic as well. It is the strong reducing agent and it can reduce carboxylic acids, nitriles, and carbonyls, which means aldehyde and ketones, can be synthesized by reacting aluminium chloride with lithium hydride, LiH. At 200 degrees Celsius, aluminium chloride exists as Al2Cl6. Okay. Draw the structure of Al2Cl6 showing fully any coordinate dative bonds in the molecule. Okay, so it means you have to show the bonds. So sometimes what students do mistake over here, they draw the dot and cross. So if you make the dot and cross, you will not get any marks. So you have to show the bonds only, which is the covalent bonds with these are shown by the simple lines, and the dative bond is shown by the arrowhead line. Okay. So we know one aluminium chloride is AlCl3, in which there are 3 covalent bonds. Then you will make another molecule by keeping the chlorine of that molecule is faced by the aluminium like this. And then from chlorine, you will show lone pair, and from dot lone pair, or okay, the lone pair is not necessary. You will make a arrowhead like this to show the dative bond. So you have to do only this thing over here. Is this clear? Okay. Now, at 1000 degrees Celsius, aluminium chloride is exist as a AlCl3. State the bond angle. So if you see, yeah, it's 120 because aluminium belongs to group 3 and it has a 3 bond pairs over here. And if it belongs to group 3, it means it has only 3 valence electrons. So there will be no lone pair. So if this is the case, the shape is trigonal planar and the bond angle is 120 degrees. Okay, lithium hydride contains lithium ions and hydride ions. So lithium ions and hydride ions. State the electronic configuration of these 2 ions. Okay, so if you see, hydrogen's atomic number is 1, and when it becomes -1, so it means it has how many electrons? 2. And lithium's atomic number is 3, so it means its atom has 3 electron, but when it becomes +1 ion, it has a 2 electron as well. Yeah, so the electronic configuration of both will be same, 1s2 and 1s2. Is this clear to all of you? Okay. Now, lithium aluminum hydride, LiAlH4, decomposes slowly to form LiAl solid and hydrogen gas. Okay. LiAlS show metallic bonding. Describe metallic bonding. Yes, who can recall the definition?
Sure. Next is the energetic force attraction between positive ions and creation of purified electrons.
Good. Electrostatic forces of attraction. That is, you have been studying since O levels. Between cations and C of delocalized electrons. You have to mention the delocalized electrons, or either you have to mention the mobile electrons, C of mobile electrons or C of delocalized electrons. Okay. Now, next part. LiAlH4 cannot be used in aqueous solution because it reacts with water to produce LiOH, hydrogen gas, and white precipitates, which is soluble in excess sodium hydroxide. So now see, this is very important thing. White precipitates, which is soluble in excess sodium hydroxide. Can anyone recall which compound is this? It's a compound. Where is iron?
Aluminum hydroxide.
Very good. Aluminium hydroxide.
Okay.
So you have to identify the precipitates. So the precipitates are aluminium hydroxide, and how you guys recall it? It's from the table of the cations and anions. See, that is you do not need to memorize it for the paper 3 because they have given you, but see, these kinds of question can be asked in the exam. So it's a aluminium hydroxide over here. Yes, very good, Zoha. Okay, now okay. Two students try to prepare 2-hydroxybutanoic acid in the laboratory. Both students oxidize butane 1,2 diol to form P in reaction 1. Okay, so okay, that is the reaction 1 mentioned over here. They have started with this compound butane 1,2 diol, and on oxidation they turn it into P. And if you see, P has two functional groups. What are the functional groups in P? And ketone. See, see here you have the equation. It's ketone, not OH. Yeah. That's our target molecule that we need to prepare. Okay. Now, one student then reduces P using LiAlH3, Q is formed. And the other student reduces P using NaBH4, R is formed. So see, that's what the difference that we have studied in when we are doing the reduction. This one is the strong reducing agent, so it is going to reduce and very good. It will reduce carboxylic acid and ketone both, and NaBH4 is going to reduce ketone only. Is this understandable to all of you? Okay, so it means when this reaction is performed using LiAlH4, the product would be, here we get an alcohol and here we also get an alcohol. So again, butane 1,4 diol is formed. Okay, but when we reacted with the NaBH4, only ketone is reduced to alcohol and the carboxylic acid remains the same. So see, this is R. So when we use NaBH4, we get the R. Is this clear to all of you? Yes, if any one of you has any confusion, please write in the chat. You have to do the practice of a skeleton. You can show me that after the class. Okay. Now, what they have been asked, state the reagents and conditions required for reaction 1. So if you see in reaction 1, there is an atomic oxygen and alcohol are turning into ketone and aldehyde, oh sorry, ketone and carboxylic acid. So it means it's an oxidation. So we can use potassium dichromate or we can use potassium magnate. Yes.
Conditions to not reaching a concentration ketone
No, it's for aldehyde. When we have to prepare aldehyde, we have to, heat and followed by distillation. But for ketone and carboxylic acid, we have to do heat under reflux. Okay, but is this only a condition?
Concentrated heated
Acidified is the other condition. Yes, Lena, what you didn't understand, please ask. See, you have to remember this thing, Lena. When we use NaBH4, it reduces only aldehyde and ketone, nothing else. But when we use LiAlH4, it reduces all the organic compounds, it reduces nitriles, it reduces carboxylic acids, it reduces aldehyde and ketone. So if I'm using this LiAlH4 over here. So it is going to reduce this carboxylic acid into alcohol, and it is also going to reduce this ketone into alcohol as well. Okay. And when we use this NaBH4 over here, so see the carboxylic acid stays the same over here. It doesn't change, and only ketone is being reduced to alcohol. Is it clear now? Okay. Now the reagent for the reaction one, as we have figured out its oxidation, so the reagent would be potassium. No, you don't write acidified because acidified is the condition. See, they have asked you reagent and conditions. So you will write either potassium dichromate 6, or the other reagent would be potassium manganate 7. And then you have to write the conditions. The condition would be heat under reflux to get carboxylic acid and ketone. And the other condition is the solvent or the medium which we needed for the oxidation, and that is the acidic solution. So you will write over here acidified solution. Okay. Now next part. Only one of the students successfully prepares 2-hydroxybutanoic acid, and we have already know that in reaction 3, the target molecule, the target 2-hydroxypropanoic acid, this one is formed, and in reaction Q we didn't get this product. Identify which of Q or R is 2-hydroxybutanoic acid. So we already figured it out, it's R, and explain the difference between reaction 2 and reaction 3. So we will first write R is 2-hydroxybutanoic acid, and then we will write the difference that in reaction 2 both ketone and carboxylic acid reduced, but in reaction 3 only ketone is reduced. Is this understandable? Okay. Now, a third student prepares 2-hydroxybutanoic acid using propanol. Which compound is it? It's an aldehyde. It's Al. All is alcohol as the starting material. In step 1, the student reacts propanol with the mixture of NaCN and HCN. Okay. So see how many carbons it has? 3. And here we got 4 carbon. So that's what happens when we use HCN with either halogenoalkane, we get a elongated carbon chain, and here as well. And which reaction is it? Very good. It's a nucleophilic addition. Okay. Then in step 2, it is refluxed in acid. So which reaction is it? Hydrolysis. Good. So it's a hydrolysis. So on hydrolysis, nitrile turns into carboxylic acid. Okay. Which other organic compounds undergo hydrolysis? Can anyone recall? Esters. Esters undergo hydrolysis. Nitriles undergo hydrolysis. Amides undergo hydrolysis. And halogenoalkanes. So these are the 4 compounds which undergo hydrolysis. Okay. Now, draw the mechanism for the reaction of propanol with the mixture of sodium cyanide and HCN to form AS. Identify the ions that react with the propanol. So which ion is going to react with propanol? See what this have asking ion. Yeah, so it's a cyanide ion. So I'm going to write over here. It's a CN with the 1 lone pair on carbon and 1 lone pair on nitrogen, and put a negative charge to show it's an ion. Okay. Then Draw the structure of intermediate of the reaction. Okay, we are done with this thing. Include all charges, partial charges, lone pairs, and curly arrows. Okay, just I need a minute, please. Okay, so we found the ion. Now we have to make the intermediate and we have to draw all the charges, partial charges, and beside partial charges, we have to draw lone pairs and curly arrows. Okay, so let's have a look. Remember, the curly arrows must be in the curly form, do not make it straight. So the first curly arrow is from here to this carbon, and you have to put a dipole over here. This carbon is partially positive. That's why the negative ion gets attracted towards this. And this oxygen has a partial negative. And one curly arrow from this bond to pointing towards this oxygen. So which is showing that this bond is broken heterolytically. So if the bond is broken heterolytically, it means that this oxygen get a pair of electron. So if the pair of electron is there, then it becomes a negatively charged. And it have a single bond with the carbon. We got a C2H5 on one side and H on the other side. And here a CN or C triple bond N, you can write in either way, gets bonded to the carbon. So we got the intermediate. So we are done with this thing as well. Okay. Yeah.
So it's bond between it's into partial positive angle and then it's into curly angle.
Yeah, that is the whole complete mechanism thing, but they didn't ask you about that. You have to complete that.
Which pairs?
They didn't ask, they just ask you to identify this thing. They didn't ask you by which thing the intermediate is going to react further.
Is that wrong?
No, it's not. So if the examiner asks you to write the whole mechanism, then you will write HCN like this with a partial positive hydrogen and partial negative CN, and attack from a curly arrow from the lone pair of oxygen towards the hydrogen, and a curly arrow from this bond to the CN. Okay, is this clear to all of you? Okay, now complete the equation for the reaction in step 2. Okay, okay, when S is heated under reflux with HCl. Okay, so as it's a which reaction is it?
Hydrolysis.
Hydrolysis. And what we have used?
HCl.
HCl.
Yeah.
So we are going to write for a complete equation HCl and then water. both. So this carbon turns into carboxylic acid. What happens to this nitrogen?
Let's say ammonia chloride.
This nitrogen, yeah, very good, turns into ammonia. But as HCl is there, so ammonia is a basic substance and HCl is acidic, so they both would react, and here you will get NH4Cl ammonium chloride. Yeah.
H plus with them. I think we'll go H here.
Yeah, so the equation would be over here. We will write H positive over here, and here we will write ammonium ion. And if instead of HCl here, it's H positive is written, then the equation would be like this. Okay, but here now it's HCl is written. So we instead of H positive, we write the complete acid. And as ammonia is formed, ammonia reacts with that acid, and as a result, we will get the complete salt. So we'll write ammonium chloride.
The fed part.
Yeah, I also got it.
Salted, so उसमें ऐसे सना.
Okay, so we are going to solve it later in the class. Okay, now we have our infrared spectroscopy. The infrared spectrum of an organic compound is shown. The organic compound is either S or 2-hydroxybutanoic acid. Okay, who is going to tell me that it's 2-hydroxybutanoic acid or not? If you guys recall, there is in 2-hydroxybutanoic acid, we have it's a carboxylic acid. OH of which substance? OH of alcohol or OH of carboxylic acid? Both has a OH. Good. So if the OH of carboxylic acid is there, then you are going to get a one big peak in this range. Yeah, that is very broad. That is like this. Okay. And beside this, due to this C double bond O, we are going to get a very sharp peak like this between 1600 to 1700. So that is not there. If you see, here we have a 1600, here we have a even till 1800. So that is not there. So it means it's not 2-hydroxybutanoic acid for sure. Okay, so what is S? S is this one. See, we have an OH and the 1 minute. If the OH of alcohol is there, the hydroxyl, the OH of alcohol, this peak, this OH is always 3200 to 3600. So see, here it's 3200 and here 3600, we are getting the peak. Yeah. Yeah. No. Yeah, it's around 21 or 2200. Let's see where it is. Yeah. Yeah, you are provided with the values. Yeah, here we have infrared. So see, C triple bond and 2200 to 2050, 2250. As it's S, so we just see that S has this structure H, COH, CN, and C2H5, right? So this OH is showing us this peak. And as we have seen that CN is going to appear its peak between 2200 to 2250. So see over here, it's 2200. And see, we are getting the peak between 2200 to 2250. So that is of CN and that is of OH of alcohol or hydroxyl OH. Okay, so there is two more different things as well that you are going to see in marking scheme, that OH of alcohol is called hydroxyl and OH of alcohol is called, it's a OH of carboxyl. So these terms you can observe in the marking scheme. for carboxylic acid and alcohol. Is this clear to all of you? Now, deduce the identity of a compound, give two reasons for your answer. In your answer, identify any relevant absorptions above 1500 centimeters. So we are already identified two absorptions above 1500 centimeter, right? So it is compound S that we have identified. And that now we have to justify it. So we'll write absorption at 2200 to 2250 centimeter inverse for cyanide, CN, and absorption at 3200 to 3600 centimeter inverse for OH of alcohol or hydroxyl. Is this clear? Give two reasons. So we are done with the two reasons. Yes, if any one of you has any confusion, please ask. Okay. Now we have a question number 4. Iodine is used in many inorganic and organic reactions. State and explain the trend in volatility of halogens from chlorine to iodine. So if you recall, chlorine, bromine, iodine, gas, liquid, solid. So what is volatility means? No. How readily it evaporates. So volatility is decreasing, right? Because the top one is a gas, the next one is the liquid, and the next one is a solid. So the volatility decreases, and what is the reason? Why? The number of electrons are increasing. More number of electrons, hence stronger intermolecular forces. Is this clear?
Yes, sir.
No, you can't write about the density, Shrek, because volatility is related to the intermolecular forces, the strength between the molecules. So you have to explain that. Okay, now next part. Explain why HI is least thermally stable of HCl, HBr, and HI. Yes.
Bond status.
So what happens to the bond enthalpy then?
It decreases.
Yeah, it decreases. So it means the bond energy or bond enthalpy of hydrogen iodide bond is lowest. That's why. Okay. Now the table shows the electronegativity values of hydrogen, fluorine, and iodine. Explain in terms of intermolecular forces why HI has a lower boiling point than HF. Yes.
HF has hydrogen bonding and permanent alkyl.
Okay, very good.
HI only has permanent alkyl. That is why, like, it is weaker than the hydrogen bonding.
Yeah, it is weaker than the hydrogen bonding, but for if for HI you will write permanent dipole forces, I think it is considered to be wrong for in this context. Why? Because see, they have given you the electronegativity values. So yeah, so if you look at HI, The electronegativity of hydrogen is 2.1 and it's 2.5. So if if the difference is lesser than 0.5, then it's induced dipole. We considered it as a non-polar. So here we are getting the difference of 0.4, and here we are getting the difference of 4.0 minus 2.1. So if you do not mention over here hydrogen bonding, because in this context we are clearly getting is that this one has a HF has a permanent dipole and that one doesn't have a permanent dipole. So you just need to write that HF has a permanent dipole forces, HI has a induced dipole forces, and permanent dipole forces are stronger than induced dipole forces. So between HF molecules, permanent dipole forces are present, and between HI molecules, induced dipole forces are present, and induced dipole forces are weaker than permanent dipole forces. Is this clear to all of you? Now, next part. Iodine reacts with hot concentrated aqueous sodium hydroxide in the same way as chlorine. So see, they are making the reference to the reaction of chlorine, which we have studied in the lectures. Write an equation for the reaction of iodine and hot aqueous sodium hydroxide. So if you recall the reaction of a chlorine with iodine, chlorine with aqueous concentrated sodium hydroxide, we were getting NaCl and NaClO3. So here I will write NaI and NaIO3 and water. Now you have to balance the equation. Remember, if the examiner doesn't ask you to balance it, you have to balance it. Yes. 3, 6, 5, and that's 1, and that is 3. Yeah. So you have to remember this, how to balance it. Okay. Now, next part. Iodoalkanes contain carbon-iodine bonds. The simplest iodoalkane is CH3I. CH3I can be made from methanol. Identify the reagent that converts methanol to CH3I. Yes. HI. Very good. HI. And instead of HI, what? PI3 can also be used. Or red phosphorus and iodine. That is also used. You have to write any one. Okay. 1,2 diiodoethane. Okay, there are 2 carbon containing compound and both carbon has one ion. Can be made by bubbling ethene into liquid iodine. Okay. Fully name the type of mechanism shown in this reaction. Electrophilic addition, very good, because see, they are saying that ethene, it's CH2 double bond CH2. And when it reacts with iodine, we get CH2I and CH2I. So it's electrophilic addition. So see, if you just write addition, you will not get the mark because they ask you to fully name the type of chemical mechanism. So you have to write electrophilic as well. Okay. Now, J reacts with sodium hydroxide, forming different products dependent on the condition used. Name J. Yes.
Two ethyl, butane है, but two something.
1, 2, 3, 4.
Two methyl butane.
So on second carbon, we have a iodine, and on second carbon, we have a CH3 as well. So 2 iodo, 2 methyl butane.
I was right about the butane.
Yeah. Okay. Now J reacts with aqueous sodium hydroxide to form K. Okay, that is a K. Okay, so it's a electrophilic or nucleophilic substitution, right? The halogenoalkane is substituted by OH. Fully name the mechanism. Yes. So nucleophilic substitution. Yeah, you can write it SN1 as well. Nucleophilic substitution. Yeah, Shred 2-methyl 2-iodo, but see, we discussed in the naming that whenever there is a halogen and alkyl side chain, so we will write the name of a halogen first and then the alkyl side chain. So 2-iodo would be written first and then 2-methyl. Okay, now J reacts with sodium hydroxide. Dissolved in ethanol to form a mixture of two alkenes, L and M. Alkene L is shown. Okay. In the box provided, draw the structure of M. So if you see over here, you have a CH3 here, CH3 here, and CH2 here, and then CH3. So if you see, in this case, the hydrogen is removed from here when the iodine gets removed from here. That's why you are getting the double bond. But there is another possibility that if iodine removed from here, a hydrogen gets substituted from this side. So when this will happen, we will get a double bond over there like this. And the alkyl side chain, you can make it like this. Or instead, if you have any issue, you can keep it like this as it was in the previous structure. Is this clear to all of you? Okay. Yeah, we just left with 3 parts to complete the paper. Yeah. See, this product they have already mentioned, so you have to write the other product. Okay. Next part, explain why L does not show geometrical cis trans isomerism. L has a pi bond. See, L has a 2 identical groups, 2 same groups on a double bonded carbon. So that's why it can't show cis trans or geometrical. L has 2 identical groups on one of carbon of C double bond C. That the carbon which has a double bond must have 2 different groups in order to show cis trans isomerism. Okay. Now, L reacts with hot concentrated acidified KMNO4 to form propanol and one other product. Okay, what is L? It's this. Very good. So when we use the hot concentrated acidified potassium magnate, if you recall, it would be broken down from here. So this, the left part turns into ketone, and the right part, if you see, this carbon has one hydrogen over here. That's why nothing is there. So if the carbon, the double bonded carbon has a 1 carbon chain and 1 hydrogen, so it turns into carboxylic acid, and this has only 2 carbon, so it will form ethanoic acid. Is this clear to all of you? Yes. So here we will get this thing. When this is broken, 1 propanol and 1 ethanoic acid. Okay. Now, last part. two parts. Propanone reacts with excess alkaline aqueous iodine. Complete the balance equation for this reaction. Okay, which product they didn't mention in the equation? Can anyone identify which reaction is this? Good. Yeah, the iodoform is not shown. CHI3. That is missing. Okay, now you have to balance the equation. So six, 3, 4. So I think 2 over here. 1 minute. Let me check. It's going to be 1. 4 hydrogen are over here. It's going to be it's going to be 3. Yeah, 6 hydrogens. See, 3 hydrogens are over here, 6 hydrogen are over here, and 1 hydrogen is over here. So how many hydrogens? 10. 3 and 3, 6. 6 and 4, 10. Okay, the equation is state one observation that can be made in reaction in C6. Yellow precipitate, that is the only observation. Okay, so here this paper is completed. Now we are going to start new paper tomorrow. And tomorrow, I think I have in the group description, you have a time schedule of the class. Check, please check. Please check. Okay, so see you everyone tomorrow. Take care. Goodbye and Allah Hafiz.